Hello everyone, Corey here with CDS Automotive again. Doing a little bit of a different video today. I just had a couple of things pop into my mind over the last couple days that I've been kind of thinking about, and I just wanted to make a video and try to elaborate on that. So I'm hoping by the end of this video we accomplish two things. You see I got a couple of questions up there. Is a lab scope, digital storage oscilloscope required to diagnose cars? And the other question I want to answer or kind of shed some light on versus answer would be the difference in the input versus the signature. And I will touch on that as we move forward. I think after we touch on the difference in the input versus signature is going to lead to an answer on the first question if a lab scope is needed. But obviously, you guys draw your own conclusions. I just wanted to make a comparison. So let's get into it. So at the bottom here on tooling wise, you can see we've got just a regular old fluke multimeter and then a couple of lab scopes here just for demonstration purposes. So I use a lab scope often when I'm diagnosing issues on vehicles for a multitude of things, whether it be NVH, electrical issues, parasitic draw testing, all that stuff. It provides fantastic documentation, test results, and proof to my customer that what we're seeing is in fact a problem, and it gives you some measurable comparisons to if a part is required to be replaced per se. It gives you some nice comparison of before and after. That along with scan data, it really comes together nice most of the time and provides excellent documentation. So I kind of was thinking of something to compare to, and I think we're going to start with the second, the difference in input versus signature. So what kind of came to mind to me was standard writing versus cursive. And what I mean by that is when you're printing, right, you need to know correct spelling and you need to know how to put the letters in the correct order. Okay, fairly simple, right? Okay, well let's apply that to using a meter and the standard printing I look at is checking inputs. So here I just drew a very basic rough example of just a 3-wire crankshaft position sensor, right? So we've got 3 lines going to it, a 5-volt, a signal, and a ground, commonly known as low reference. Simple enough, right? Sensor, powertrain control module. And, if you look at standard printing, we need to know the correct spelling, in the correct order, obviously. So we need to know what each of these wires is responsible for, right? This would be an input to the crankshaft position sensor. This would be an output out of the crankshaft position sensor, and this is low reference, this is ground. So this is going to the crankshaft position sensor. Simple enough, right? So we need to know what we would expect to see on each of those wires. Now, if we're using just a multimeter, typically you're doing a static test. So you're checking for your voltage here, here, and here on each one of those lines. Okay, that's going to get you to a point in your testing, right? It's going to get you to a certain point. But after that, are you going to be able to draw a conclusion if what you're seeing on each one of these wires statically is correct? And that's where we move on to the cursive. So, for example, not only do we need to know how to spell and how to put letters in the correct order, but we need to know how to tie it together. And this is the crucial point, guys. You need to know how it ties together. So if we go over to our diagram here, we need to know how mechanically this ties together to the electric portion of the system to be able to properly troubleshoot this. So if we know we're supposed to see, a 0 to 5 volt square wave and we see an issue within that signature. So when you look at a scope, when you're viewing the screen and you're gaining a signal, specifically on a crankshaft position sensor in this case, we would expect to see a zero. We'll just say a 0 to 5 volt square wave, pull to ground, 5 volt, pull to ground, 5 volt. Okay, when you're using a multimeter like this, you're not going to see that. Okay, and it's important to realize this because, checking your inputs to your sensor is absolutely crucial. But like we see in the difference over here, how to tie the whole system together, how to tie everything together is where we come up with accurate test results as non-invasively as possible. It's always the goal to not take things apart unless we have test results driving us to the next step, in which sometimes disassembly is required. By being able to use a scope and check the signature out of this sensor, that gains some incredible insight. That can lead us to see mechanical issues with the tone wheel. That can allow us to see air gap issues, whether that be rust or previous installment or something of that. We can see missing teeth on the trigger wheel there. On the target wheel, excuse me. This is all incredibly important because in this case, a meter is going to get you, a meter is going to get you to here, right? So we can check here back, typically statically. What we really want to do is dynamic testing. So when the issue is present, we want to see everything as much as we can, obviously. So we want to see the signature of that crankshaft position sensor to help narrow down our area of concern. So you guys, I know it's an often talked about topic, but I think it's important to realize, and I thought that might have been a good comparison because, you don't typically learn cursive before you learn to print in the alphabet, etc. Okay, so knowing how to write, that's fantastic if we're talking about it from that aspect. But you won't necessarily be able to make a usable signature. And excuse my cursive, by the way, I'm not the best at it by any means. But to get the whole picture, to do both, we need to have one to then get the other. So if you're using just a meter, and not using an oscilloscope, I think, at least from my experience, you kind of get to a certain point within the testing and then find out that, you suspect that maybe it's a crank sensor, okay? But you don't really know what kind of condition the target wheel's in, the air gap, etc. Okay, and you can inadvertently fix issues, as we all know, by, say, removing that sensor, checking with a borescope, trying to measure the air gap. So for a lot, and continuing moving forward with vehicles as more and more technology gets rolled out on these platforms, I think it's incredibly important to realize this and implement a scope when necessary. It is not always completely necessary, do not get me wrong. However, there's a lot of things that can be discovered non-invasively by using an oscilloscope versus just a multimeter. Remember, a multimeter is only going to get you so far, whereas the oscilloscope, we're really starting to get the whole picture encompassing the system that you're looking at. So I hope this was a good comparison. You guys, if you like the video, like, subscribe, share, and let me know your thoughts on that. I always like hearing about different opinions or testing techniques and all that. So thanks for watching, guys. I know this is a bit longer, but I was hoping just to kind of, shed a little light and maybe compare it to something that maybe would make a little bit more sense versus a go or no go. Like, yes, you absolutely need a lab scope, or no, you don't. Like, I think I was just trying to draw it out to show the benefits and kind of the drawbacks of the just using the meter, and then the benefits of using the scope. So thanks for watching, guys.